Comparative study of power quality enhancement. Using SRF theory, SMC, and TSMC controlled dynamic voltage restorer. Abstract. In the present year we face the power system issues. One of the major power system problem is associated to power quality. Power quality issue is occurred due to a current, variable voltage or variable frequency, so the failure occurred in at load side voltage. One of the sever issue related to power quality is power sag. To resolve this problem, the dynamic voltage restorer, DVR, is used, which is one of the most methodical and potent modern custom power device exploit in power distribution networks to solve power quality issue. The advantages of DVR is it's smaller in size, lower in cost, and it's fast in dynamic response to the external disturbance. In this research paper, modeling, analysis, simulation and comparative study between three different control methods which are -1, SRF theory, it contained Park-S transformation controlled dynamic voltage restorer, DVR, 2, sliding mode control, SMC, it is the combination of SRF theory and SMC, and 3, terminal sliding mode control, it is the combination of robust and SMC, finite time convergence for fast response, high accuracy, and strong robustness by using a MATLAB, 2018, Simulink model. Keywords: power sag, DVR, dynamic voltage restorer, SRFT, synchronous reference frame theory, SMC, sliding mode control, TSMC, terminal sliding mode controller, voltage sag, MATLAB simulation. Introduction. In the power system, the power quality issues analogous to voltage sag, voltage swell, harmonics. Voltage sag is the most extreme severe disturbance in the distribution network. To reduce voltage sag, custom power devices are used. 1 DVR is one of the modern custom devices, which is the most proficient and compelling. DVR is solid-state device which is associated in series. The device inject voltage into the distribution network system to control the load side voltage. DVR is usually introduced in a distribution network system between the supply and the critical load feeder at the point of common coupling, PCC. Other than voltage sags and voltage swells compensation, DVR also has different attribute like line voltage harmonic settlement, a decrease of transients in voltage and fault current limitations. The dynamic voltage regulator, SAPF/DVR, contain of a voltage source inverter, VSI, with a depot element on the DC side. The capacity of the DVR to eliminate low-frequency events is exclusively a result of the control algorithms used to get components of a reference voltage. Arun, Thorat, Department of Electrical Engineering, RIT, Islampur, Maharashtra, India. A DVR is a conventional power device which acts as a harmonic isolator to obstruct the harmonics in the source voltage transpire at the load as well as balancing the voltages and furnish voltage regulation. Fig. 1, DVR series connected system. 2 Dynamic voltage regulator, DVR. The dynamic voltage regulator, SAPF/DVR, contain voltage source inverter, VSI, with DC side depot element. The VSI is associated in a series with the network through an isolation transformer. Shown in Figure 2, the regulator behaves as a controllable source of reactive power to accomplish desired voltage regulation. 5 The capacity of SAPF/DVR to diminish low-frequency components because of the control technique exploits to pull out components of reference voltage. In this paper, SRFT for control of DVR with an additional attribute of the selective harmonic compensation to enable DVR as power conditioning device. The main components of DVR: first components is an injection transformer, second is DC charging element, third is depot devices, fourth is a voltage source converter, VSC, fifth is harmonic filter and sixth is a control and protection system. The simulation study gives the comparative study of the system without sliding mode DVR, system with sliding mode controlled DVR and terminal sliding mode controlled DVR. The comparative analysis is done by observing a reduction of supply voltage harmonics and voltage sag restoration ability. 1. Simulink model for system with DVR without sliding mode control. The Simulink model for system with DVR is shown in the following figure 8. DVR part in the Simulink model consists of control technique block for controlling inverter operation, i.e. to control voltage, IGBT based inverter for injecting voltage in the system, LC filter for removing harmonics generated in the system, and 1:1 isolation transformer for providing isolation. The control technique is based on the SRF theory, i.e. synchronous reference theory. The control technique is based on Park S transformation i.e. covered ABC parameter to DQ parameter for easier control, and inverse Park S transformation to convert DQ to ABC parameter. We can independently control active, D, and reactive, Q, components of current and voltage. Is shown in the figure 5. Fig. 6, see restored supply voltage. Figure 6, A, to figure 6, C, shows that during fault condition the voltage will restore by injecting opposite phase voltage in the system. The supply voltage is restored to some extent than that of the uncompensated system, but the sag isn't restored totally. Likewise, the voltage supply voltage, which shows that functioning of DVR is not satisfactory or the results of SRF theory is not good. Fig. 8, THD of restored supply voltage. From figure 7, it shows the load voltage THD is 36.37% during sag period, and from figure 8, shows the THD of restored supply voltage without SMC DVR, it is reduced to 5.13%. 2. Simulink model for system with sliding mode controlled DVR. To reduce the voltage THD, the system is simulated utilizing a SMC algorithm. The supply voltage is restored with SMC DVR. Proposed control strategy is explained earlier, and the same is applied in the Simulink model. The proposed control technique is first convert supply current, injected current, and injected voltage are first converted ABC to DQ domain using Park S transformation. Second step, all converted parameter given to sliding mode equations, and then the output from sliding mode equation which is in DQ domain, so again it converted into ABC domain using inverse Park S transformation. By using PWM technique, the switching signals are provided to the inverter. Conclusion. The DVR is cost-effective solution to mitigate voltage disturbances. A sliding mode controlled DVR is used to remove power quality problems. The TSMC control technique is used to remove power quality problem with robust nature because TSMC is combination of two controller, i.e. robust control, RC, and sliding mode control, SMC. The proposed technique of control is based on SRF theory with the control law of the SMC and TSMC, robust and SMC, generate control signals of DVR. The all three control method explained in this paper will enhances the power quality by compensating a different kinds of power quality problems, such as voltage swell, voltage sag, harmonics and transients. The simulation results for different methods. 1. Without SMC DVR, SRF theory, system THD is reduced up to 5.13%. 2. With SMC DVR, system THD is reduced up to 4.32%. 3. TSMC DVR, system THD is reduced up to 3.88%. From simulation results, the efficient method is TSMC DVR as compared to SMC DVR and SRF DVR.